Find the partial fractions decomposition for 1 over x to the fourth minus 81. Let's start by taking the denominator and factoring it. X to the fourth minus 81 can be factored as a difference of squares into x squared minus 9 times x squared plus 9. This first term is a difference of squares, so it can be factored further as x minus 3 times x plus 3. And the second term is a sum of squares, and so it's irreducible, can't be factored farther. That means that 1 over x to the fourth minus 81 can be broken apart as a term over x minus 3, a term over x plus 3, and a term over the irreducible x squared plus 9. The numerators will be an a and a b for the first two. The second term contributes two letters c and d in the form of cx plus d. Now to work out these four coefficients, we need to put everything on a common denominator of x minus 3 times x plus 3 times x squared plus 9. The first term requires an x plus 3 and an x squared plus 9 to be on the common denominator. The second term requires an x minus 3 and an x squared plus 9 to be on the common denominator. And the third term, cx plus d, requires an x minus 3 and an x plus 3 to be on the common denominator. So we have this giant expression here, which is equal to 1 over x to the fourth minus 81. Since the two fractions are equal and the denominator is the same, we can focus on the numerator. Now let's pick some test values. If we select x equals, say, negative 3, we'll have 1 is equal to, the first term cancels. The second term becomes b times minus 6 times 18. And the third term cancels. This gives us negative 108b is equal to 1, and so b is negative 1/108th. And so we will replace this b with negative 1/108th. For the next test value, let's try x equals 3. We'll have the equation 1 is equal to a times 6 times 18 plus a 0 since this term cancels, plus another 0 since the last term cancels. This gives us 108a equals 1, or a is equal to 1/108th. So we can replace this term by a 1/108th. Now we need another test value. X equals 0 will at least kill the c term. So let's try that. We're going to get 1 is equal to a times 3 times 9 plus b times negative 3 times 9 plus d times negative 3 times 9. If we clean this up a wee bit, we're going to have 1 is equal to 27a minus 27b minus 9c. 9d. Knowing that we know a and b, this simplifies to 1 plus 24 1/107ths minus negative 27 1/108ths, minus 9d. And so we get 1/2 is equal to negative 9d, or d is equal to minus 1/18th. Some nasty fractions. Now let's go and replace the d up top with negative 1/18th. We need one more test value to find the last one. So x equals 1 is as good a choice as any. This is going to get us 1 equals a times 4 times 10 plus b times minus 2 times 10 plus c plus d times minus 2 times 4. So that's going to get us 1 is equal to 40a minus 20b minus 8c minus 8d. And now we can replace a, b, and d with their known values. This gets us 1 is equal to 40 1/108ths minus negative 20 1/108ths minus 8c minus 8/18ths. That's 4/9, but it would be better to write it in terms of 27ths, so let's write that as 12 27ths. What we find is we have 1 is equal to 1 minus 8c, which means that c is equal to 0. That's a little anticlimactic, but you never quite know what you're going to get, so we can eliminate this term entirely. And now we have the partial fractions decomposition for this function. We can also write it as 1/108th times 1 over x minus 3 minus 1/108th over x plus 3 minus 1/18th times 1 over x squared plus 9 as an alternate formulation. And this is our answer.